So what I would like to do, I got some thinking help, that instead of iterating through the entire board and looking for every single piece on the board, I can just flip the logic and iterate through every single move sequence and then look if there's a piece intersecting at any of the points. So I think that will make it so much easier. I will add the same for loops as for the renderer. I guess I could just make these a constant auto, because now we are working with the actual coordinates. So what I could do is check, maybe I do want a function for this. Let's just do is colliding with, and I can add the constant chess piece and then the coordinate, and I will return piece.x equals coordinate first and piece.y equals coordinate second. What I also was thinking of doing was, instead of using a pair, I could create a struct called coordinate with an x and a y, because I think it's kind of confusing that these are called first and second, because it's not that explicit what they do. So that might be my next thing to fix, but I'm gonna make this work first. So we're checking if the x's are the same and the y's are the same, and that should be enough. Let's just do if colliding with, and we want to pass in the pieces at coordinate x, first. See, I'm already messing it up. And then the coordinate. I think that's fine. Actually, it's not gonna be fine, I just realized. If I divide these guys by the entity size, then we should get the piece at that specific position. I'm not completely sold by this, but I'm gonna try. What I can just do is print collision detected. So for example, this guy right here, he should be at 0 on the x and then 448 on the y. See, I'm not getting any collision. Maybe I'm doing this wrong. Maybe this should be second and first. And the reason for that is because I am using the height and the width like that, not the width and the height. Let's just see if we detect any collision now. Collision detected. Okay, great. So that's good, that's good. We just have to flip that around. So we got the collision detected. Now, what I want to do is, maybe I can do something really smart here. What if I make a remove colliding moves? Or let's just make it remove moves for now. So what I want is a move sequence reference, and then I want an offset. Kind of how you're like erasing elements from a string or a vector, so you can offset where it should start removing. So let's do auto it is move sequence dot begin plus offset, and then it is not at the end, and then I'll do move sequence erase it. Maybe that's what I have to do. Let's try. Remove moves. We want the move. I think I'll have to do this like that. These have to be arrows. And then I have to pass in the dereferenced pointer, or just the depointered, or whatever that's called. And then I can pass in the offset, I think. I'm calculating the distance from the begin to the coordinate, and then I'm gonna start removing from that offset. We're getting some errors. Requires a narrowing conversion. Let me just change this to size t. Size t. Maybe I have to include the std def. Okay, let's see. What are we getting here? Pointer diff. Okay. Alright, let's see. Alright, we are getting an error, of course. We are getting the 0448. We are erasing it. And then, okay, so we are erasing something, but then we're getting the error. I am thinking of adding a function for removing the out of bounds moves. We want to do move, erase. Can I do coordinates? I don't think so. Like that. And then if coordinate second is less than 0, or coordinate second is greater or equal to window width. We wanna erase coordinate. And then we want to call that in here. And we are getting an error again. I think I have to do this. I remember doing this in the top-down shooter game. We have to actually reassign the iterator because we're invalidating it when we're doing erase. So then we're setting it to the returned iterator, which should be the next element. That's why. And I have to do the same thing with the remove moves here. Maybe I have to add continues here. And then after this, I'll just do like that. So I can remove that. Because when I'm reassigning coordinate, going to the top, then I'm incrementing it for every iteration. But I don't want to do that if I remove an element. Only if there are no removed elements, I want to increment the iterator. So that should work. Great, great, great. Now let's do the same thing for remove moves, because we're erasing it. So we have to remove it and do that. Let's see. Yep, there we go. It is removed. Let me combine these guys up here, since they are doing the same thing. We're checking X and we're checking Y. So that's a bit cleaner, I suppose. So this function should be fine now. So let me make another function here. Remove colliding moves. And let me put all of this in that function. Like that. And then we don't have to return. I don't think that's necessary, really. So we are moving. That's removed. We're moving here. That's removed. Perfect. Now we just have to add the moves back when the piece moves. I wonder if I could do... I'm gonna try something here. What if I clear the moves every time he moves, and then I do set moves? So we're completely regenerating the moves, and then we are fixing with the out of bounds and the colliding moves. Might work. Okay. We're gonna have to fix that too, of course, but... Hey, so far so good. And then this guy, obviously gonna have to fix that. What about him? Okay. Looks better. We just have to add these guys too. And then with the king is... Yeah, we gotta fix that too, of course. And then the queen. Yeah, it's looking a little messy right now, but that's fine. It works. We're making hella progress, I would say. And just to make this a bit easier for myself, I will call the clear here to make sure we are working with a clear vector. And that should be the exact same result. Yes. In the colliding moves, let me add a new variable here called current piece and just put that in there. And then just check the current piece because I want to use it here. By checking if the current piece dot color equals piece dot color, because we should not be able to kill our own opponents. That would be a very ridiculous chess game. So then I guess we could just do coordinate equals move dot erase. What if we do that? If it's our teammate, then we want to remove that part, and then we want to continue, which means we should remove that. And put that right there. I should also call remove colliding moves like in here somewhere. Maybe I can call it here. Because in the beginning we shouldn't be able to move this guy at all. That's right. And then we have to fix the thing with the same type. Oh wait. Are we stuck in the for loop? Yeah, let's just do that for now. That should be fine. Now we can move again. Perfect. Alright. So we gotta fix that. And that, but as you can see, he can now move out. I think I got it fixed. Oh, almost. Guess I don't need that continue because I wanna calculate the new offset based on the piece I removed. Let's see if that works. No, still able to move out. That's not good. What if we just do this afterwards? So we remove the moves and then we reset this guy. Maybe I just have to erase that and then break. I don't know. Okay, there we go. But I should, yeah, I'm able to move those. And same with these guys. So that one can move out. This guy, exactly, he's able to hop out, which is great. Perfect, okay. Now we finally got it to work. This was a motherfucking headache, but it works. So let's remove the comments and let's remove this pane. God damn. So glad I remade the update moves function. Oof. So the out of bounds works, the colliding moves works. Add new moves, we don't need that anymore because we are calling the same set moves function. I could also make a function here called kill opponent. What I could do is when I move a chess piece, I want to check if the piece is colliding with. I want to pass in the piece. Then I want to pass in pieces, piece.x divided by entity size. Actually y, my bad. Entity size. And then the piece.x divided by entity size. I think I'm gonna need these guys like that. And then wrap those like that. Might be a bit ugly, but that's fine. So let's just print for now. Opponent killed. Let's say we are moving this guy there. We're moving him there, and we are moving that guy there. Okay, so we're never getting any print. Right, because I'm calling piece.y. Maybe I can make another one where I just compare two chess pieces. Let's name them first and second, and I want to check if first.x is equal to second.x and first.y equals second.y. And then I can just do that, and then I have to get the piece from the board. So we're checking if there's a piece on the board right there, then we should kill the opponent. So let's do the same thing. We're moving that guy out, moving him out there, moving him there, and opponent killed. Perfect. Maybe we can add a kill function here where I do destroy texture, and then I just do this is chess piece, so I just destroy it. And then I can just do... I could just do colliding chess piece dot kill. That should wipe him from the surface of the earth. There we go. He's gone. Now the king is gone. Perfect. So we got most of it to work. I do guess I can actually make a kill opponent function. Is that gonna be misguiding? I think that's fine, as long as it works. Let's get the horse out of there. Oh, hold on. He should be able to move there. That's interesting. Oh, the fuck, he disappeared. Maybe I have to check that the colliding chess piece.color is the same color as our own. Before I do that, I'm just gonna check if he removes after 2 moves. Yep, let's add that back and see if that's the issue. Nope, something else kills him. Okay, so somehow I got it to work anyway, with the knight disappearing. I don't know what I did, and I don't know why that move is gone. So I have to fix a few things with the moves, because this is also still missing, which is quite interesting. So basically what I did was just do that. Alright, yeah, I added that part too. So I'm checking the coordinates and that the colors are not the same. And in that case, it is killed. What to do? What to do? In the set moves function, I need to update a few things, I believe. Yeah, he's still missing a few moves. That's kind of fucking weird. Okay, so he does get it back when he moves out of the range. But as soon as I step in, it's gone. Okay, now it's back. What? Alright guys, so I am back after basically a year of recording the chess tutorial. And I finally figured out why the moves for the knight wasn't updating correctly. So the problem was in the remove colliding moves. So basically what I had before was this. And now all I have is this. It's not that different. The only thing I'm doing is I'm checking if I'm colliding with the piece and it's the same color. Then I remove the coordinate and I just continue. And otherwise I just increment the iterator. And now it works. So if I just go ahead and build this. Oh, and by the way, as you can see, I've switched to Sea Lion because I just like it better. So yeah. And if you want a tutorial on how to migrate from Visual Studio to Sea Lion and get the SDL2 library to work, then just let me know and I will do that. If I go ahead and run this, you can see it's all the same. But now when I click, earlier I had a collision right there, which didn't get removed. I could just move there, but now that's gone. If I move there, now I can only move to the free spaces and no longer here. And if I move down, then these guys can still be eliminated. So yeah, everything seems to be working just fine for the night. But I believe there are some more things I need to change, obviously, otherwise I wouldn't be recording, but yeah. So as you can see, the pawn is still being able to move twice every time. So I guess that's what I will be fixing. And before I do that, I'm actually gonna go ahead and just apply most of the Sea Lion suggestions. And I'm just gonna go ahead and clean up the code a little bit. I wonder if I could move this out, because I don't think I need to be creating this object every time. I just need to set it and then set it on the board. And the same thing for the chess piece. Let's just go ahead and try that. Make sure everything works. Yep, everything seems to be fine. Well, that's good. So let's just go ahead and clean up the code a little bit. I'm just going to these yellow lines and seeing what's wrong. Like, obviously I don't need a return statement there. It's the end of the function. And this can be const. Yeah, I guess that works just fine. And then, like here, I'm not using the char. This doesn't need to be initialized. This is also what I like about Sea Lion. If you miss a few things, then Sea Lion got your back. They're like, hey, you don't need to do this or do this instead. And then you just do that and all is good. Then do the multi-cursor life hack like that. What I could also do is actually order these better. There we go. Why is he crying on the color? Add const. Why? Nah, we're good on that. I'm guessing like for the actual parameters, I rarely put const, only if there's a reference to explicitly tell yourself and the compiler that, hey, this is a read-only object and we don't want to copy. And I actually want to rename these guys because I don't like the casing. And these should be small. There we go. That looks much better. And these could actually also be initialized just to give them a default value. And I could actually do not set for both of them, just to have a default value. Before I continue, I guess I could start making functions for these two, just to break it out. We got the pawn first, so we want to set the pawn moves. And then we have set, I guess we could do rook moves. It's only 2 lines, so I might skip that for now. So let's just move on to the knight. And then we have the bishop is only 1 line, no need. We set king moves. And then we got the queen, only 3 lines, kinda necessary. So I'm just gonna do that. Get the chess piece reference and let's create these functions. And then we want chess game in front of it, so the code knows that it's a class function. And let's start cutting out some code. These need to be static too, of course. Like that, and like that. Now we have separate functions for these, so I could just minimize them. Now set moves is way easier to read, so that's good. That's fine, but this is not fine. And what I want to do is create another function. Handle poll events. I will create this down here. Then I want to take all of this code, place it with handle poll events, then put that in there. And obviously I need to pass in the piece to move. Basically I'm gonna get rid of this, and I'm gonna make the handle poll events return a bool. And I'm also gonna pass in a chess piece. And up here I could just do return false, and then get the chess piece. And I might actually have to make this a pointer just to make sure I don't mess anything up again. Condition is always true. Yes. So if I'm pressing escape, it's returning false. And then way down here, I want to return true. Condition is always false. That's not true because I'm doing stuff to it here. Okay, let me just pause that for now and start working on the cleanup of this code. So you see this right here wraps all of this. So what I instead can do is just remove that, press enter right there, and then switch this. So if it's not mouse button down, I just want to return. Actually, this should just be continue, I believe. We're gonna keep looping. Then we can make another function, handle piece click, for lack of a better name, and maybe also make a handle piece move. Then we are checking if the piece has been clicked, and if we are waiting for a move, then we are going to do that. Now we have to do handle piece move for the piece to move, and then handle piece click for the piece to move. And I wonder why it says all of this. Let me just backtrack here and see what we're actually doing. Wonder what would happen if I actually put this below the render function. Okay, I mean, it works just fine. That means that we can take all of this code, including this part, cut that out, handle poll events, paste all of it in there. Now, we don't need this, don't need that. Gonna complain, but that's okay, because we're gonna move this guy right here to here. Now the code looks happy. Let's do handle poll events right there. Just like that. Unreachable code, okay, that's fine. Could also just do this. Game is running. Might be a bit unconventional, but it's fine, I suppose. So now it's basically the same, just broken out. And the warning is gone. That is perfect. No return statement, that's fine. This can be void now, because we're not supposed to return anything. We're just supposed to set this and then break. Okay. I actually didn't know, but you can make a reference to a pointer like this. You learn something new every day, goddamn. I had no clue. Now I know. So, that's great. Now this is fixed. And now I can take this and do the same thing. Handle piece move. And put that here. There we go. And now I want to do the same thing. Alright. And I could do the same thing as I did earlier. I just do continue there. Let's see if it works, or if it's still broken. Okay, kind of blinked. Ah, I know why. I actually need to move this guy. This has to be here, and then I have to pass it in here anyway. Because this is running every loop, and it's creating the pointer every loop. But I also wonder if I could make it static. Trial and error. Trial and error. Yep. So static seems to be working. That's good. And we don't need all of those parameters to the function. So that's good. All right. It's looking cleaner. Now the update is simple. It's broken out into functions. We like it. I think we can move on to working with the pawn. So we have these set pawn moves. What I'm thinking of doing, this might be ugly, since the pawn always spawns on 64, I would like to check that if the y is 64, then the pawn can move twice. And if the pawn's y is greater than 64, then he can only move once. And then do the same thing for the white, so check right there, and then, yeah, you get the picture. Pawn has moved. If piece dot color equals piece color black and piece dot y is greater than, let's do entity size times 2, because that's where the pawn is, then we wanna do something there. And we then want to check if the piece color equals white, and I'm doing white because I now have the not set, so I just wanna make sure that nothing funny happens. And the piece.y is less than window height, because that's gonna be 512 minus entity size times 2. I think we could work with that, because that means we are checking if it's less than this. Okay, let's try. Yeah, I think that's fine for now. Yeah, we can also make that const because we're not changing it. Return false. Now we want to check. Guess we could do moves multiplier. Then we want to do, so if it has moved, we want to do 2, otherwise 3. And this goes here. So let's see if it works. The pawn hasn't moved, great. Now if we move, there's only 1. And there we go. Yeah, that is exactly the desired outcome. Great. Also had a comment, limit amount of moves for pawn after initial move. Could also rename this to vertical move sequence. Because what I want to do is I'm thinking of doing this, right? I'm looking through the board. So the y should be the pieces y plus entity size, so 1 down. And then the x should be piece x minus entity size. Okay. So they're basically just blank chess pieces in the middle, which is fine for now. But that means I can do a little check here and see if the piece type is not equal to piece type not set, so it's an actual piece. Could also do that. Const int piece y offset, const int piece x offset, like that. Actually gonna make 2 of those because we're gonna look left and right of the x-axis. Or do we need to? I don't think so. Actually, we just need the vertical multiplier again. Do piece.color equals piece color black, and the vertical multiplier is 1, otherwise -1. And now we can do piece.y plus entity size times vertical multiplier. So if it's 1, then we're gonna add 1, otherwise it's gonna remove 1 entity size unit. Now I can just put the piece offset y there, and then we're gonna look for that first, and then we're gonna need another one for the plus. Could also do constant chess piece left colliding piece, left colliding piece, do the same thing, right colliding piece, do the same thing, but this is gonna be plus on the x, and we're gonna check if the colliding piece is not set. If I'm colliding with the left one, I want to return chess piece. Nope. Return left colliding piece, right colliding piece. We could actually make 2 functions. Now I'm just gonna break this out into another one, like that. Like that. We could also get a little expected up in here and do std expected, then do std reference wrapper const chess piece. Like this. Now I want to return this because that's the expected value. Otherwise, I just want to do std unexpected false and then get it right there. Can also do using expected chess piece type like this. Just shorten it down a little bit. If get ldiagonal piece. Could also do ldiag result if this is good. Sorry, this should not be there. If this has value, then we want to add a move sequence ldiag. Oh, can I spell? Thank you. To in place back. What do we want to add? We want to add the ldiag result get x and then get y, and then do piece add move sequence ldiag sequence. And then we want to do the same thing for the right diagonal for the piece. If the right diagonal has a value, create another move sequence there. Right diag, do right diag sequence, and place back. Basically the same thing. And then add the move sequence, just like that. I wonder if that would work. And I guess we also have to check if the left colliding piece color not equal to the piece.color. And the same thing here, just so we don't get moves to our own chess pieces. Let's see if that works. No. Oh, you know why? I think it's because I have to divide this by entity size. Get the actual position. Okay. Looks fine. Now if we move down here, there we go. And actually the pawn shouldn't be able to take the piece right in front of it. Only left and right. So that's interesting. I think I actually want to change this to void. Remove the const. And then do everything in this function. Like this. And then I just want to basically do the same thing. But instead of returning, I'm just going to do it right there. And I'm going to do right colliding piece dot x and colliding piece dot y. And I need to return, just do that. And the same for the left. Remove that, strip that away. Do it right there. I want the left colliding piece. There we go. To remove this, I can remove expected. And I'm gonna rename these to set right diag moves. And then the same thing for this, set left diag moves. Could make one for set vertical moves. I think I'm gonna rename these so it's clear that it's for the pawn only. But for now it's fine. Can't I spell today? Thank you. This too? Are you fucking kidding me? What's wrong with my spelling? Now I basically want to move all of this into set vertical moves for the piece. There we go. Paste that in there. Now I want to make sure that constant chess piece vertical piece should be the pieces piece.y plus entity size times vertical multiplier. And I'm gonna have to take all of this, divide it by entity size. So we got the y, removing one size unit down or up, and then we are dividing it. Could also simplify this a bit by doing a constant int piece offset y, divide it by entity size, and then do piece.x. So it's gonna be on the same x, but the y depends. Now we're gonna check if vertical piece the type is not equal to piece type not set, then we want to basically do everything. I could also just do this. So if it's not set, then we just want to return. We don't want to add another move sequence below it. If there's a vertical piece right below or above the pawn, then we just don't add any moves because he shouldn't be able to move any further. So that should be fine. Right. Yeah, I'm doing it the wrong way. So if this is not set, if there's a piece in front of it, then we don't add it. That's why I flipped the motherfucker the wrong way. There we go. Now we can move, and now when we move there, we can no longer move forward. Great. We can still move to the side, and that gotta be fixed. We just gotta add some out of bounds things. How about that? We're checking if we are to the far left or to the far right. That should work. We're moving down, we're taking that, and there we go. Now he can't move anymore. Great, great. Looking good. So guys, that's gonna conclude episode 5 for creating the chess game. I know I didn't do a lot of things in this video, but I've been recording for a while, and I think episode 5 is gonna go over like 40 or 50 minutes if I keep going. So I'm gonna break it up into smaller pieces and continue working in episode 6. So thank you so much for watching, and I will see you later.